what this will do is it will read a formatted JSON file to actually make loading more complex shaders a lot easier. So what we've got here is the JSON file we're going to load. It has a few key elements. So shader program is indicating that we're creating a new shader, and this is the name of the shader that we're going to create. Then after that we have a list of the shaders to attach, and in this case vertex shader, which is called Fong vertex, and then a list of individual shader files which should be loaded, and these are effectively concatenated together to form one big shader. So in this case I've got a very simple one which just has the GLSL version in. Then I've got one here called common, which has just got all of my structures and uniforms which are going to be available to both of the shaders. And then the next one in this case is my actual vertex shader code, which in this case is just my sort of sample Fong vertex shader. You'll note that there's no versions at the beginning of all of these because this will cause an error. So that's why I've got that single file called version, so I can include that first. For the fragment shader, in this case I'm using the excellent noise functions from the WebGL demos, which are linked on the README for this demo. And so I'm loading in version, common again because it's going to use some of the same structures. Noise 3D in this case is a whole load of functions that are just going to be included for doing my noise elements, and then the actual fragment shader itself, which comes here. So this allows us to create a lot more complex shaders. Rather than having one big uber shader, we can split different functions together and things like that. And when I run this, it will load in, or just using those noise functions, we can change different parameters to make it look different as it goes through. That's just basically changing a repeat on the UV mapping, which is being used to drive the actual simulation of the shader each time. So we get some quite interesting results, and it's quite nice. So this should make sort of developing more complex shaders a lot easier in our sort of GLSL demos. And it's not 100% foolproof. The JSON parsing is pretty robust, but it may still give you shader compile errors. If it does that, it's because you've done something like added hash versions and things like that. To look at the actual code, there's a method in ShaderLib called loadFromJson, and I'm using RapidJSON as the parser. It goes through, makes sure that the document is correct, and then goes through checking for certain members, try and validate that it is a correct thing. As I say, it will bomb out on errors if they're wrong, and it's using most of the back end of the standard shader library. So this is just a new extension to make experimentation a lot easier. I'll most probably add a few extra features to this as we go. The next job is going to be to write a tool to write out the JSON file for us, which will be quite a simple Qt sort of wizard, and that will write out nice valid JSON for us. So that's the demo for today.